Hello guys, yeah, good day. Sorry for the delay. So we'll be starting our webinar session. Today's topic would be about the Easy Wi-Fi Planner. For those who doesn't know, the Easy Wi-Fi Planner is a tool that you can use so that you know the minimum number of access points that you're going to deploy on a certain area depending on the layout. So some of you guys may have accessed the Easy Wi-Fi Planner before through our partner portal. Some of you may have not. So let me show you guys where you can access it. From our website, engeniustech.com.sg, on the Partners tab, you can go to Partner Portal. And then from there, it's going to bring you to the Partners Portal page. If you haven't registered before, you can register by clicking on the Join button. If you already have an account, by the way, you can just create a free account using the login buttons right here. So once you have an account already, you can proceed with the login. Okay, so here under the partner portal account, you have a lot of options. Actually, you can get a lot of information here, such as the upcoming webinars, some information on our products. We have some files as well to give you more information specifically on how to use our items. And then under the Easy Sell tab, this is where you have your Easy Wi-Fi Planner. So once you select that, it will open a new page. And then from here, you can start to create projects. So as you can see right now, I have a lot of projects filled in. You can create up to 50 projects per account. Yeah, so from here, you can create up to 50 projects. And let me start to create one right now so you guys can see how it works. So when you create a project, you have to fill in the project name. And then you can select the country. So the country here will reflect what channels you can use for the specific access points. So earlier I created a project, but let me start all over. So I'll be importing a new floor plan. This is the first step that you need to do. So you can rename it anything that you want. This one is a new option to use Google Map as a reference instead of uploading an image. Later on, I'll demo that to you guys as well. So from the image side, you can select any type of image files from the system. You can't use PDF. In case you want to upload PDF files, I suggest to take a screenshot of that PDF and you upload that instead. So let's say you want to upload one of your floor plans. You just select that from your files. The first thing that you need to do once you upload your floor plan is to set the scale. So this is so that you know that the actual range of your access point, the simulated range, is the correct value. So right now, the floor plan that I have uploaded, I just grabbed this from the internet, is actually scaled already. Here, let's say for example, here from one end to the other, this one is set to 25 feet. So I'm going to set my marker over that and set the scale from here. So let me put this as 25. So once you have scaled it, then you can already apply the obstacles in the map. But first, the thing that you need to do is select the Wi-Fi zone. So Wi-Fi zone basically tells the system which part of the area you want to cover it with Wi-Fi coverage. So select the Wi-Fi zone, and then drag it across the map. Let's say for this whole area, I want Wi-Fi to be covered for here. That means I can deploy my ABs on this whole area. So I cover that with a map, and then you can start laying out your obstacles. If this Wi-Fi zone is like obstructing your view, you can hide the layers actually. So Wi-Fi zone, let me disable that for now, so that we can start plotting the obstacles. So under your obstacles, you have a lot of options such as a wood, concrete, light door, windows, etc. So let me start laying out the concrete side. So let's say I know that this material is made of concrete. So I can do the layout as such. So it may take a lot of your time to do this part, but it will help a lot in terms of showing the heat map. So let me jump to the pre-made one that I did earlier. So it's the same map. It's just that I plotted the obstacles already. So I plotted the concrete walls, the wooden doors, the glass windows as well. And then actually I also placed the elevator shaft here as well. I mark it as an elevator. So you can select that under the next button, which is the area. Here you can select what type of area that part of the layout is. For example, you have an elevator shaft, you can just select that from here and then drag it across where your elevator is. So whatever obstacles that you place here on the map would reflect the heat map coverage of the access point. So let's say you're already done with the scale. Let me just confirm if the scale here is correct. Yeah, seems about right. So if your scale is correct, your obstacles are there, the next thing that you can start to do is add your access points. There are two ways that you can add access points. One is automatic placement. That means you let the system decide how many APs are going to be placed depending on the size or the scale of your map. Second is manual placement. So for example, I'm going to be deploying the ECW120 on this map. So here, if you select add access point, it will bring you two tabs. One is for indoor APs and then the other one is for outdoor. So for this indoor deployment, I'll be deploying the ECW120. Or maybe I'll change it to Wi-Fi 6 model, ECW220, 2x2 Wi-Fi 6. So let me select that instead. So here, try to make an estimate first where you want to deploy the AP. Let's say here under the bar area, the event room, I want one AP here. Maybe this testing area, I'm going to place one as well. One on this side behind and maybe another one here at the lobby. So these are the estimated placements of your access point. Of course, you can quickly move them around later on, or you can add or delete some. Before I check the heat map, you want to go under the inventory first to check on the settings of your access point. So under your inventory, this is where you can relabel your access points. You can modify the name. For example, AP1 is on the lobby side, AP2 is on the kitchen, and so on and so forth. The other things that you can change here are the modes. You can set the APs to Mesh Access Point or WDS. You can modify the channel as well, but you can also let the system, the ezWiFi planner, set the channels automatically for you. You can set the channel width, most importantly, the power setting. So by default for 2.4, it's set as the lowest, 11 dB. For 5 GHz, it's 17 dBm. So let me set 2.4 and 5 gig to about the same value. So let me set both to 15 dBm. Sorry, something's wrong with my mouse. It's not letting me change the channel. The power. But if it doesn't let you, you can also double click on the access point and modify those settings from here. So let's say I want to set the transmit power to 15 dBm for both. So you can adjust that per access point. Okay, so now that they're both set to 15 dBm, you can try to check your heat map coverage for both 2.4 or 5 gig. So let's check on the 5 gig side, because usually that has a lower transmit power. So for 5 gig, you can see on the map that this is my estimated coverage of the access point. It takes into account the obstacles that you have already placed. So here, under the signal bar, you have your legend. Red means strong signal. It goes weaker to yellow, to green, to blue, and white. But in case you want the reverse, you can also do that. You can just click on that button right here to change the represented color values. You can either make white the strongest, red the weakest, or the reverse. So by default, red is the strongest signal. And then if you mouse over certain parts of the map, you would see the estimated RSSI as well. For example, here at the loading bay, RSSI is about -60. So if I need Wi-Fi in this area, maybe I need to adjust this AP closer or move it to a different part of the map so that I can spread a good coverage of my Wi-Fi signal. So the one on the event room seems about right. It's covering this area. The one on the lobby covers the stage until this part as well. Tasting room is also okay. So the only parts that I have... Wait, let me move that back. So the only parts that have weak signal are the staircases and the lavatories. So if you want to know whether 3 access points is enough to cover your area, you can also like move one of the APs out of the way, and then you can check the coverage from there. So again, the Easy Wi-Fi Planner helps you determine the minimum number of APs that you would need on an area depending on the Wi-Fi coverage or the signal coverage. But this doesn't take into account the number of users in the area. For example, here, let's say we're expecting like 1,000 users, but you can see that 4 APs is already enough to cover the area. Of course, to support 1,000 users, you would need to have more access points as well. So it's up to you to add more access points depending on how many users that you want to manage. Usually for every APs, we max it out to about 120 users estimate per access point. So that's the coverage for 5 gigahertz. If you want to see 2.4 gigahertz coverage, you can just switch the band from here. So this is 2.4. As you can see, even though it's using 15 dBm as well, same with 5, the coverage for 2.4 is wider or farther in terms of the frequency range. Basically, the lower the frequency, the stronger the signal, or the farther the reach. So earlier, the channels would set to auto. So if you go to your access point, you can enable some of the labels as well. So AP name and the channel. So right now it's set to auto. So during the planning phase, you can already start to plan out what channel you want your AP to be set to. Instead of doing it manually, you can let the system do that as well. So all you need to do is under the device menu, click on auto channel, and it's going to select the best channel to set for all your APs. So right now it changed it to 1611 for 2.4, for 5 gig 136.52, and so on. You would notice that some of the APs have the same channel. Like for example, AP2 is on channel 11 for 2.4. Access point number 3 is also on 11. That's fine because APs 2 and 3 are quite far off from each other, that even if they are on the same channel, they won't really have that much interference. Let me clear out the APs first. So let me show you guys another method to add the APs. So if you have no idea like where you're going to place the AP, maybe the client haven't mentioned where they want the AP to be, what you can do is click on Advisor, so that the system will decide automatically, depending on your floor plan, where to plot those APs. So using Advisor, you have to select what model you want to deploy. So let's select the same model, ECW120. And then what radio you're going to use to benchmark the AP placements that you're going to need. And then the transmit power that you require, as well as the minimum signal strength for the given area. Let's say for your whole floor plan, you don't want the signal to drop below negative 65. So I'll select negative 65 from here. So it will maintain this RSSI value throughout the whole map. So once you run it, it's going to take a while for the system to decide how many APs it's going to put. So right now I can see that the system added quite a number of APs. So let's wait for it to load up. So the first thing that the system will do is place a number of access points and then determine which position to put those access points on for optimization. Yeah, so the current image file formats that are accepted are basically any image file like a JPEG, bitmap, GIF, and PNG. Those are accepted. PDF and let's say for example DWG files, you would have to take a screenshot out of it to create a picture format first before you upload it on the system. Okay, so it placed access points on the map, but I think it's not optimized. Wait, let me try to optimize it again. So there's another button right here. Let's say you've already placed like now there are 9 access points. If you want to optimize the positions, you can click on Site Optimizer on the top. And then it's going to show you a warning that the access point positions will be moved around. So let's run that. So based on the parameters that you have set, negative 65 would be the weakest part of the signal on the map. This is what the system determines to be the number of APs and the position. So here it suggests to use like 9 access points if you want negative 65 RSSI to be the weakest point on your map. But of course, the placement here may not be optimized as well. Because for example, on this position, maybe you're not allowed to mount the access point on this side. So you can easily shift that somewhere else. And if you think there's too much access points on the area that was advised by the system, you can always delete an access point. So yeah, but once you delete an AP, which is less than what the system have advised, that means some of your areas may have signals that are lower than -65. So let's leave this at that. Let me make a few adjustments. Okay, so let's say this is what we have for the coverage. If I'm not mistaken, the channels have already been set as well. So yeah, it has been optimized too. If you want to re-optimize the channel, you can do that anytime. You just click on auto channel from here, and it's gonna set that automatically depending on where the APs are. Okay, so let's say for example that not all these access points are gonna be utilizing a wired connection. Some of them would be through mesh. So let's say this AP right here, and let's say the 3 access points in the middle, they would be my root node, and then the rest of the APs would be your mesh nodes or WDS links. So you can also draw a path here using a mesh or WDS. So if you're gonna do mesh, it's pretty straightforward. First, you have to click on this icon right here, the mesh icon, and then select which radio you're gonna use for mesh. So I'm gonna be using 5 gigahertz. I selected 40 megahertz as my channel width, and then you can name your mesh group. So for the sake of convenience, let's say this is group A, and I'm gonna use channel 36 as my mesh link. So I create the group, and then from here I can start to add which access points belong to this group. So let me add all these APs as part of that mesh group. Because for mesh, you don't have to determine which one is the root node, which one is the mesh node. That's done or analyzed automatically by the system. So let me edit this group and select the APs that I want to add on the group. So as you click on them one by one, they'll be highlighted in orange to let you know that they belong to this specific group. And then select done. And then now it shows the mesh connection. So basically for mesh, all the APs would be interlinked together using a star topology. And you can see that topology from here. So you can see, for example, the AP nearby one another have a stronger connection. It shows me the distance. For example, here to here is about 18 feet. Here to here is 30 feet. It tells me the RSSI signal as well. So the obstacles that you have in place will also reflect how much signal loss there are between access points. For example, from this access point going to this one, it's pretty close. But as you can see, the signal quality is pretty much low. That's because I have like 1, 2, 3 concrete walls that are blocking line of sight between these two APs. So for the mesh, it gives you a pretty good idea on how you can handle mesh. But what if you want to do WDS? So let me clear out my mesh group and let me change the models to something that supports WDS. So there's an easy way to clear out the APs as well. You can go under your inventory, highlight all your access points, and just click on remove. So that will remove all the APs on the map. So let's say I'll be using WDS and I want to use maybe the EAP. Okay, so EAP 1300, let's add maybe about 5 access points. And let's say this 2 right here are my root nodes, so the rest are wireless. So again, WDS, you select which model you want to link through WDS. So this one is wirelessly connected to my root node, so I can draw the path from there. So you can do the same for the rest. So you can clearly see the difference between WDS and mesh. For mesh, it's done automatically by the system. For WDS, you have to manually trace the path from one AP to another. So once you have set your WDS links, you can click on this icon right here to show you the connection quality. So it shows you the distance from AP to AP. It also shows you the signal quality. If you add more obstacles, you would notice that the signal will drop as well. So let me try to add one wall here. Okay, maybe let's add 2 just to show you guys. So earlier this is about -44. The moment I added another couple of walls, then you would see the signal drop. So it could simulate as well how much signal drop you would have depending on how many walls you have on the area between your access points. So after you've done your layout, you can upload multiple as well. So let's say this is a multi-story building. You can upload multiple floors from here. You can upload up to 10 as of the moment. So we'll be expanding this in the future. Later on, Nancy will talk about that part. So earlier when I added the floor plan, I showed you guys that you have 2 options. You have an image as well as Google Maps. So let me show you guys how it is if you want to add access points on Google Maps. So let's say outdoor layout. Okay, so this is Google Maps. Let me find our office. Yeah, that's about here. So let's say from here I want to deploy wireless hotspots for outdoors. So you don't need to scale it anymore because Google Maps is pretty much already scaled. So all I need to do is select the access point you want to deploy for outdoor. Maybe let's say ECW 160, our cloud 2x2 wave 2 access point. So when deploying on Google Map, you can also set the height of your deployment. Okay, so let's say I'm deploying 3 APs. So from here, you can also link them through mesh, or you can do WDS as well. But there's a difference on the heat map. So here, the heat map is calculated based on an open space. Unfortunately, right now, it won't be able to calculate like the buildings and between the elevation. But what you can see is the estimated heat map coverage of each access point in an open space, in an open environment. So with its default settings that I have, right now it's maxed out, 23 dBm on my default antenna. Here I can see the coverage of my access point on an open space. By the way, when you double click on the access point, you can also have additional information such as the antenna pattern. You have that for 2.4 and 5 gig. And then you can also add an antenna. For example, this is the ECW 160, so you can use an external sector antenna to add. So you can add a sector antenna from here. And then it will show you the direction where that antenna is facing. So yeah, I mentioned that right now on Google Maps, it won't be able to show you like the obstructions in between. But what you can do is a workaround. So instead of using the Google Map option from here, actually you can just take a screenshot of this map and upload it as a floor plan. So let me show you the other one that I did. Okay, so basically I took a screenshot of Google Map and then uploaded it as a floor plan. So to scale it, since Google Map has a scale, it will be easier to do that from here. Let me reset the scale. So here to here, it shows that it's 50 meters. Let me change the metric. So now you can estimate the coverage of your point-to-point links as well. So for example, I want to deploy, let me set the Wi-Fi zone. So for example, I want to deploy the end station. Maybe I have a couple of end stations and one ENS620 EXT in between. So let me select the end station 5AC. Let's say it's on this side of the road. Another one here on the opposite side. And then let me add a base station. Okay, so let's say my base station, wait, let me move that further down. Okay, let's say my base station is using a sector antenna. So I can select the 2x2 sector antenna from here. And then for outdoor deployment and directional models, you can actually tilt the AP where it's facing. I'm not sure if you guys can see it from here, it's a bit small. But basically if you click on it, there is an arrow which you can rotate where the device is facing. So let me face that on my base station. And then the antenna direction, you can also tilt it. So with the set distance and the transmit power of my access point, right now it's set to maximum, you would be able to estimate the coverage as well. So you can see from here that the signal pattern of this device is different because the End Station 5, or basically the End Station models, are using directional antennas. If you can see, if I tilt it towards this way, you would see the direction moving there. And then, assuming that this is an open space, if you want to know how much the RSSI is between one point to the other, you can set your WDS links. So same as for indoor, this End Station 5 will be linked to this base station. So with this other one. And then from here, you can see your estimated heat map, your RSSI. So distance from here to here is about 181 meters. That's about 19 dBm. It's pretty short because I'm using a sector antenna. For the other side, it's about 285 meters, 26 dBm. If you want to know what's the RSSI level without the sector antenna, you can easily check that out as well. So you just remove this sector antenna. So now your ENS620EXT would be using its default omnidirectional antennas. So as you can see, the coverage is pretty low. If I check the WDS link, you can see a huge signal drop. So now it's -51. So again, for outdoors, we're not able to determine the obstacles yet, but you can basically try to simulate that by adding more obstructions from here. Select the specific obstacles. But yeah, for point-to-point links, this would work as well. Let's say, let me clear off the WDS links. Okay, so let's say now I'm setting two point-to-point links, maybe from one end station AC to another end station AC. So let me phase them to one another. And then set my WDS link between the 2 points. And then right now you can see that it's about 569 meters apart. Signal is still okay, -36, assuming that you have clear line of sight. And then when you set your heat map coverage, you would see it this way. So if your end stations are misaligned as well, let's say one is facing up top, the other one is facing the correct direction, you would see a drop on your RSSI level too. Okay, so now I have tree layouts. Let me remove the ones that I don't need. Yeah, so now I have tree layouts. The nice thing about the ezWiFi planner is that you can generate reports based on what you did. So just click on report right here on the upper right side. First, it's going to give you a summary of all the layouts that you have. Layout 1 is my indoor scenario. It shows me the map, shows me the AP location, AP list, all your settings as well. Signal coverage for 2.4 and 5 gig. And then WDS, if you have the links, that will be displayed too. For my outdoor scenario, this is my AP point-to-point. And then my outdoor hotspot. So if you want to generate a report, just click on download report on the upper right hand side. It's going to generate that on a PDF format. So test Singapore. And then select the floor plans that you want to include on that report. So it's going to take less than a minute for the PDF file to be generated. It's going to take longer if there are multiple floors on the system. But once the file is ready, it would show as a download on your browser. Okay, so here you can see that the file is about 11.6 MB in size. And when you open the file, it's going to show you that in a template. So it would show you the name that you keyed in right here. Location, I'm not sure if I keyed in Singapore just now. The date when you created the report. It's going to give you the table of contents. A summary, basically a disclaimer. And then it's going to show you all the floor plans that you have, depending on how many you have uploaded. So a while ago I uploaded 3, basically 2 floor plans and 1 Google map. It's going to give you an estimate coverage area, how many ABs are there. So the first floor plan would be the one I set to end stations. So this is the map, and these are the two end stations. It will show you the AP name and the channel as well. So each AP setting would be listed out too. So I didn't touch any of those settings, so it just shows me default. And then the signal coverage. So 2.4 it doesn't have because this one is a single radio 5 GHz device for end station 5 AC. So it shows me the estimated heat map. And then since I have a WDS link, it would show me that as well. So for the Google Map plan, it has additional set items right here, such as the latitude and longitude on Google Maps. I don't have a WDS link, so this part is blank. So if you have mesh, it will also show you that here. And then finally, the indoor floor plan that we did. So it's going to show you your Wi-Fi zone. It's going to show your obstacles and the AP location as well. And then your estimated heat map coverage for 2.4 and 5 gigahertz. Yeah, so as of the moment, we have a simple floor plan tool as well for the cloud. But we haven't added integration yet with the ezWiFi planner. So soon, the floor plans that you have right here, or the projects that you have, you'd be able to import as well if you're using the cloud's single sign-on feature using the EnGenius partner portal account. Okay, so there are a couple of questions right here that I think Michael have already answered. Yeah, one question right here is the advisor on the ezWiFi planner placed more APs than what was set on manual. Because manually I placed only like 4 APs, and then advisor suggested more 9 APs. Is that fine? So yeah, that would all depend on how much minimum signal you want on the area. So when you click on advisor, you can set the minimum signal strength that you want on your floor plan. Let's say, for example, you set it to -75, then advisor would suggest less APs. But if you want really good signal, especially if you're using it for VoIP or streaming on that area, then we recommend at least -65 to have good enough signal for VoIP and video streaming. Okay, yeah, that was like walkthrough of our ezWiFi planner. There have been changes on it, like the additional buttons that I mentioned just now. Also, if you notice that when you generate reports and when you generate the heat map, if you've tried this before, it's way faster right now as compared to the previous version. I see somebody raising his hand. Please go ahead. Okay, if 4x4, what is the design consideration or guideline on signal propagation from floor to floor? Right now, we cannot determine that from the ezWiFi planner, but we have plans to add verticality as well, so that it will consider the access points that are on the upper and lower floors. By the way, again, to access the ezWiFi planner, that would be through our partner portal. You have to create an EnGenius account to be able to access the ezWiFi planner. So again, from our website, on the partners tab, click on partner portal, and then on the partner portal page, you can either log in or create an account. Okay, if no more further questions, I guess that's all the time we have today. Again, thank you guys for attending, and thank you for joining today's webinar. We'll be updating you guys again on the next webinar for next week. So thank you guys for attending today. Have a good day.